Let's have a look at inverse functions together, guys. Another very important area for us to understand. What is an inverse function? Well, it is the result of taking a one-to-one function, which by now I hope you understand what that is, and swapping x for y and y for x. Note well, it can only be a one-to-one function which is used to create an inverse. Okay, so if you take a many-to-one function, remember functions consist of one-to-ones or many-to-ones, but if you take a many-to-one function and swap x and y, you'll end up with a one-to-many, and that's not a function, that's a relation, guys. Okay, so you can't do that. It has to be a one-to-one function that you start with to make an inverse. Now, because the inverse is a result of directly swapping y values, making them x and vice versa, the original and its inverse are exact mirror images of each other about the line y equals x. This is a feature of inverse functions. For example, if f of x was 2x, then the inverse would be denoted as f to the minus 1 of x. That's the notation that you use for an f notation for the original, and will be f to the minus 1 of x is a half x. Now, there's the original, 2x, there is the inverse, which is a half x, which is the mirror image of the original function about the line y equals x, you see? So for f of x, we let y equals 2x when we're doing the algebra, because you don't swap x and f, you swap x and y. So you start off by letting y equal 2x, by definition, and then you say for the inverse swap x and y, therefore x equals 2y. Okay, that's how it works.